Good morning, good afternoon, and good evening. Thank you everybody for watching this video. This video is a follow-up to our prior webinar where we developed some ideas and learned a little bit more about what a UNS is, Unified Namespace, and some deeper topics to it. I have Frank here, Frank Galuska, our Senior IoT Engineer, and I, both from Ectobox, are going to get into some specifics about building out this UNS in this UNS series. So today is building a UNS part 2b. The last webinar, we had thought that we were going to be doing this machine connectivity, taking the data all the way to a Canary historian where you can see the data. But then we stepped back and realized we needed to dig a bit deeper into the unified namespace and talking about functional and hierarchical, et cetera, namespaces within the UNS. So if you'd like to dig into the details of what a UNS is and see us talk about actually building out the structure of that UNS, check out the prior video. Link should be in the description of this video. Today we're going to dig into the deeper topic. So actually, let me step back a little bit. This whole UNS series is to be able to show everybody the value and understand the technical how-tos of how to work with a unified namespace. So we've had a couple sessions about planning the UNS concepts, defining it, and actually building out the structure of our potential namespace, what it's going to look like. And today we're going to get our hands really dirty. Well, Frank's going to get his hands really dirty and show you how to actually connect to the machine with UDTs, get the data into an edge namespace, do this work in Ignition specifically today with a HiveMQ MQTT Sparkplug B data broker, and also then get the data into Canary. So ultimately, we're going to be connecting, collecting, storing, analyzing, and visualizing the data today. Subsequent sessions are going to get even more interesting. Get into an MES. We'll bring out our MES box, a solution that we use for many customers. Build out the UNS even more, and then integrate with other systems like the CMMS, ERP, et cetera, over time this year. All right, with that said, then let's dig into the UNS. Ultimately, what we're really trying to do is to build a working demonstration of an actual plant, of a plant with multiple interactions with systems, and for all that data to come together into the UNS and represent the model of the business and how it's running in real time. Last time there's a nice eye chart for you. We had built out a bit more of this namespace. I'll show you a nicer view of it here, where we defined more of our edge namespace within the capper, and talked a bit about some of the things that are going to be coming up, include our functional namespace for the work order under the line, and some of the other data that we're going to be defining. So with that, great opportunity to actually get down to it. Specific steps we're going to get into. We're going to start off by finalizing the model with UDTs and Ignition. Frank's going to show you how that works. We're then going to see the UNS built out, the edge namespace built out in the UNS using the tag browser in Ignition. We're going to connect to that machine from Ignition using OPC UA to connect to the PLC, pull the data from OPC. Then we're going to turn around and publish that data into the MQTT data broker. Then we've got Canary Labs on the other end as a historian to subscribe to that MQTT data broker, pull it down, store it, and then we're going to view some of that data in Axiom. And then, but wait, there's more. We're going to add a second machine and then show how this whole process works a little bit more automatically, if you will. The idea of a UNS is that it should be edge-driven, among a couple other ideas. And using MQTT as the data broker, we're going to push data into the data broker. That data will automatically be available for Canary to consume, and Canary will automatically recognize and be able to display that new data in Axiom without a whole bunch of setup on those in-between pieces. And this is a basic illustration of what we're going to do. So we'll take a quick look at this before we turn it over to Frank. So Frank, while we're taking a look at this visual, anything you want to highlight, anything that's going to be pretty darn interesting as we go through this whole process on your computer?
Yeah, I think the one of the most unique things about the unified namespace in this architecture is the ability to, easily add new data to it.
There you go.
We'll see that towards the end of this demonstration of, how to add data to that UNS and get it up to the data broker, and then with the correct subscriptions and wildcards, have it automatically populate out to um, those other platforms that are subscribing to it.
Awesome. Good. Okay. Everybody buckle in, and if you celebrate Easter, settle in with a few Easter peeps, as Jeff Nepper would from Flow Software would like us to say. And let's have some fun. So I'm going to stop sharing, Frank. Why don't you start your sharing? All
Okay,
right. So first is finalizing the model. Yep, I can see your screen. Let's
yep,
get into the UDTs.
yeah. So I'll hop over to the Ignition Designer here, and I have the tag browser sort of blown up. Normally, it's docked in the left-hand side here. Um, can but you can see I'm in the UDT definitions tab here, and I have a couple already defined. So I have my analog input, digital input, capper, and a OEE tag. So I'll just go ahead and edit this analog input, for example. And you can see that that UDT has subsequent tags that are part of it. I have a PV for my present value, which will be a float data type. I have my set point, um, or SP, which is also a float, some high and low limits for alarming, and then a deviation also for alarming. So all of these sort of feed into my overall capper. So if I go ahead into my capper UDT definition, you can see I have a couple of instances of other UDTs. So I have this edge folder here, and inside there I have my heater temperature, and that is a analog input. So you can see I have that instance already defined, and I have those parameters we just saw in the analog input section. Similarly, for the run OEE, I have my three components of OEE, my in-feed, my out-feed, and my reject. And this is a instance of a UDT inside of another UDT. So you can really sort of layer things and build up these namespaces pretty easily here in Ignition. So if I wanted to, for example, add a new sensor or new piece of data to this capper, I can go ahead and click on the level that I want that. And there's this button here. I can add a new analog input source. So I get a new instance of that UDT. Maybe this is a pressure sensor I can add. So I'll just name it as such, hit apply. Page will refresh, and you can see I have that pressure sensor here and already have the subsequent tags to go along with that UDT. So very simple to build out all your edge information and data coming into one UDT, as well as those other namespaces such as the run OEE and the other fun stuff we're going to get into later in the webinar series here.
So it's as if you're using that analog input as kind of a template UDT, and then you're implementing that as you create specific sensors within this edge namespace. And then that makes the process of creating each of these UDTs for pressure sensor, heater temperature, et cetera, faster, easier. Is that fair?
Yeah, that's exactly correct. Yeah,
Awesome.
I like to think of things as starting with sort of the base level building blocks, and for me that's the four data or four data input types. So you have analog inputs, digital inputs, analog outputs, analog or digital outputs. Um, so those four IO types are sort of my building blocks, and then I go from there. So I can define my edge namespace and all the other contextual data with the piece of equipment or a machine.
Awesome. Okay. So then, is there anything else to add here before we move to taking a look at the UNS?
Um, I I think we can move on from this. Yeah.
Okay. So then let's take a look at this. I think, is it in the tag browser then to actually take a look at what this is going to, how this is going to be organized from a UNS, a unified namespace structure with the namespaces?
Yeah, so I'll switch over to my tag section here.
Yeah.
And you can see I already have an instance of that capper defined. And I have my unified namespace set up following the ISA standards. So I have my enterprise evective box, site of Pittsburgh area bottling line 1 for my line, and then my capper cell. And underneath the capper cell, I have my edge namespace with the subsequent UDTs we were just seeing over in the UDT definitions, as well as that run OEE tag.
Awesome. Perfect. Is it time to get our hands dirty connecting to a machine?
I think so, yeah. I'll switch over here to the Ignition gateway. So if you're not familiar with Ignition, just real briefly, this is where all the configuration takes place with Ignition. Is where you connect to databases, machines, set up users, all that fun stuff. So I will just switch to the configuration tab here, and it'll ask me to log in. And I can go to this menu on the left and go down to my OPC connections. You see I have a Siemens OPC connection, but I can go through and create a new one as well. OPC UA, just need the endpoint URL, which is just the IP address of my PLC with the port number. It automatically detects the data source there, and I can select the endpoint and finish my connection. I don't have any security or anything set up type of connection just for ease of use. But I can go through and you can see that my status switched to connected there. So I am now connected to my PLC, and I can actually go to a quick client here. And just for example, go to my bottling line and grab my heating temperature.
So that's showing the data that's in the PLC running right now.
Yep. Yeah, so these are all tags in the PLC right now. So I
Awesome.
can click on read here, and you can see I got a value of 251, and my quality is good. So I'm actively connected to that PLC. All these tags are coming in, and they are available for me to use in Ignition.
Okay. So at this point, then we've connected to the PLC. Then we need to start looking at the model, I believe, modeling the data.
That's right. So now we need to, marry this data that is coming from the PLC with the UDTs and structure we defined already. So I'll switch back to the designer, and I can expand my heating temperature here, and I can edit my PV tag, and I can select a OPC source. So I will browse that connection we just made, grab my heating temperature, hit apply. You can see that value coming in over here on the right. It's reading, I can actually expand this tag. So quality of good with a value of 187 and updates as new values come in.
So then you have to do this for each of the data points at this point?
Correct. So I'll go through and set up my set point as well. Browse to the tag I want to connect or associate with that data point. And I can do my in feed, out feed, and then my reject is just a simple subtraction of the two.
So you're actually working a little bit in the functional namespace of the run OEE as well, getting ahead of the game. It's good.
Mm-hmm. Okay, so my in-feed and out-feed are set up. You can see I currently have a in-feed of 965, a out-feed of 644, and then the difference being the reject of now 322. So have those coming in. I have my high and low limit coming in, my PV, which is scaling with my heater that the PLC is controlling, and my set point of 300, which it's ramping up to.
All right. Is there anything else to do here before we start to grab the data and publish it to the broker?
No, that is the next step. So then we have data coming in. We can use that data here in Ignition, or we can, like Kevin said, publish it to a data broker for other platforms to use as well and subscribe to. So I will jump back over to my Ignition gateway. And for this, we are using a Cirrus Link module. It's the MQTT transmission module. So I have a cloud instance of HiveMQ set up that I'm currently connected to with at this URL. So all I had to do in order to set that up was copy the URL from that instance on the HiveMQ page. I set up some security with a username and password, and then Ignition went out and made that connection securely.
I should note too that what we're going to do in the description of this video in YouTube is we'll throw in links for setup of these various products so that everybody can see what's going on and get their hands dirty and do their own setup as well.
Mm-hmm. So you can see I'm actively connected to that data broker. And I can switch over to my transmitter tab here, and I can tell it, make a new transmitter. Here I have a capper transmitter with a tag provider. So that is referencing this drop-down menu here in Ignition. So webinar, so the new one I made for this demo. And then what the tag path, anything underneath the this section will be published. So here I'm telling it to publish everything underneath the enterprise of VectorBox and the site of Pittsburgh. So switching back to the tag browser briefly, that is the entire bottling area, all of bottling line 1, and of course my capper cell that we've been working with. So all that data will be published to the cloud data broker, and I am giving a group ID and edge node down here at the bottom as well to publish that with. So I will go ahead and save that, and I can switch over to my MQTT Explorer. I'll disconnect real quick. You can see I have that same host in with my username and password. I can connect to that data broker, and here we have the Sparkplug-B topic with Ectobox and the data Pittsburgh, and here is that bottling line. It's a little difficult to see, but I can expand it a little bit here. And the history comes in as well. So you can see that bottling line 1, capper, edge, heater, temperature. And since this is Sparkplug-B, this is encrypted data, so it's secure. So you can see that live data coming in from all of those, from that whole namespace that we defined earlier in this video. And this is now available to applications such as Canary. So we can subscribe to it, historize that data, and use it with some of their visualization tools or other platforms that can connect to and subscribe to a data broker.
Awesome. We're moving right along. This is a pretty quick process. Feels faster than I kind of expected, I guess.
Yeah,
right.
I mean it's not too complex once you sort of get everything installed and making the connections is it's not too difficult.
Yep, fair. All right, so data has come from the machine into Ignition. We've created our models, UDTs, UNS structure in the tag browser. Data is now being published into the MQTT data broker, HiveMQ in the cloud. And we have the MQTT Explorer here simply to connect to that broker to confirm what's going on and everything's being updated. Now the data is available real time, and we're going to switch over to Canary to pull the data down to subscribe, pull the data down, model it a little bit, I think, in Canary, and then store it, and then we're going to visualize it.
Yeah, so MQTT Explorer is just a simple MQTT client just to I like to use just to test the connection, make sure the data broker is receiving information, and then we can worry about other platforms that actually want to do something with that data, such as Canary. So I have my Canary admin open here with all the different modules and tools that they offer. So I can go to my MQTT collector and switch to the configuration tab. And you can see I have a instance of, I just named it cloud set up. I'll minimize these other ones for make it a little bit easier to focus on. So automatically Canary generates a client ID. I just left that alone. I told this it was a Sparkplug-B connection, and I set up my server connection again. So same URL that we've been working with to my cloud data broker, again, connecting with my username and password, and enabled SSL connections to make sure that that information is passed to the data broker and I'm connected securely.
So you have this already set up, but when doing the setup process itself, if you've got the URL and the authentication information, etc., pretty straightforward process, pretty quick process to set up.
Yeah, it's simple as hitting this plus button here, adding a new section. I can call it Kevin, for example, and then just filling in that information here with the URL, the username and password, whether or not you need SSL or TLS for that connection. And then the most important part is the subscriptions. So by default, Canary will set up to just subscribe to anything coming over the Sparkplug-B topic. We could refine that to be more specific for our Ecto box, Pittsburgh, and then that wild card. So we get everything underneath that for that specific site again. And then the dataset prefix, this is where Canary is actually going to store the data. So, Canary being a historian, it'll make a new data set with the prefix of whatever you put in here. So by default, this is MQTT data. We could change it, to the site name. And for the connection I already have established, I just defined it as the enterprise of EctoBox. And I also set it to automatically log any tags. So again, just any tags that come in over this connection will be stored into the historian with this data set.
One of the nice things about the topic, though, too, with these wildcards is that you don't have to pull everything for the Pittsburgh site. You could pull everything for the line or for a cell. You could get pretty narrow and pull very specific information if you wanted to, not the whole thing. Is that fair?
Mm-hmm. Yeah, absolutely. If you wanted to only pull specific information, you could, set up a connection and essentially hard code one specific topic path in there. You're only pulling one topic. But that's sort of the nice thing about MQTT. You can get as specific or generic that as you want. It's really up to you how you want to configure things.
Awesome. All right, so we're connected to the MQTT data broker using the MQTT collector. How about we store some of this data?
Yeah, so I have just over here on the status tab, I have my cloud connection running. I'm connected, I'm subscribed to 25 tags, and I'm logging 25 tags. So I can go to my historian, for example, and let me back up. Here is that Ectobox data set, and here is today's date. So you can see the tags coming into Canary here. And I can actually click on one in my in feed, for example, and get a view of the history. So I get that TVQ timestamp value quality that Canary captures, as well as and see the data over time.
So how did you set up this data set in the first place? I mean, as soon as you connect to the data collector, it didn't, automatically happen and create a data set and start storing it. What did you have to do to get that done?
That's actually it does do that, Kevin. When you connect to the
You mean this is
when you,
magic? Wow.
yeah, when you set up the MQTT collector and enable it here, whatever again with the subscription section, the dataset prefix. So that ecto box I defined there, and since that didn't exist, they create that Canary created that data set, and any information that came in
Nice.
from this MQTT connection was logged to that data set.
Awesome. Okay. Makes sense. Good. All right. So you've magically created a data set. Data is being stored. We can look at the data. We saw some of it there. TVQ, timestamp, value quality. Uh, what's next? So we've got the data coming in. I think it's time for Axioms, all right?
Yeah, that's right. So now we have this data being stored in a historian with Canary. They offer visualization tools such as Axiom. So I can switch over to this tab here and I can make a brand new chart. So, sorry, can go with a new chart and add trends to that chart, and you see that whole structure that we defined. So Ectobox, Pittsburgh, bottling, line one, the capper edge, and then my UDTs. So I have my heating temperature, my PV, and my set point. That pressure sensor we defined earlier. So I can go through, click as many of these as I want to put onto this trend. And let's say I just want to compare my PV and set point for now. So I'll hit add and close. And by default, Canary will show you the last hour worth of data. So you can see my heating temperature cycle over that time. I can adjust this scale to say last 15 minutes, get a little bit more of a detailed look as to, and you can see that ramping up more smoothly and dropping back down. My set point's been steady at 300. So we can go ahead and analyze that data using Canary and
Why
the
don't you
Axiom tool.
go back in and add, just to show how easy it is to add in the pressure sensor PV and SP.
Yeah, I'll add the in feed and out feed if that's all right. Those are a little bit more variable. So I'll throw those in here, and that was simple enough just by clicking on the plus button up here and get the same menu as before and just adding the points that I want. I'll throw my reject in there as well.
All right, so we're seeing that data too.
Yep, so you can see my in feed and out feed coming in. My heating temperature is still coming in as well. And if I wanted to, this is a view I use a lot, I can actually go ahead and save it. I can either make it public or private to my specific user. So I'll just call this webinar.
So at this point, we've gone as far as visualizing the data that's in the historian now as it's coming in. And there are other things we can do from a visualization perspective, like create apps with various visualization components. I would suggest we hold off on that a little bit and use that as a cover for the next step. So what we're going to be doing next is to add a second machine. Frank has, well, you can explain in better detail, but you have the POC mimicking a second machine. And so what we'll do is add a second machine from Ignition, data published into MQTT, and then Frank will show you some more magic, nothing up his sleeves, to see how that data comes in automatically within Canary as the result of the magic of MQTT, if you will. And then there is a bit of a delay for that to happen. So while we're waiting for that data to come in, Frank, I think it might be a good idea to then just create an app to show some of the other visualizations within Canary too, because the Canary as a product, Canary Labs is a great company, great people, and fantastic product too. So, okay. Machine number 2.
Yeah, so for that second machine, I switch back over to my Ignition tag browser here. And let's say, maybe the bottom line has 2 cappers, right? So I can right click on my bottom line 1, do a new tag of a data type instance, and I can select my capper. And let's call this, just to keep things simple, we'll just call it capper 2. So with that, just by making that second UDT, you can see I already got all of the subsequent UDTs that were associated with it. So have that edge namespace with my heating temperature, my pressure sensor, my run OEE, and I just need to go ahead and you can see my PV and set point are not configured. So I'll just define those again. So I'm just going through, picking my data server, which is the Siemens PLC that we're using for this webinar, and browsing to those tags of my second heating temperature PV and the secondary set point. So you can see I have that PV coming in again. It's ramping up to that set point, and I can do the same thing with my in-feed and out-feed. Oops. Find my out-feed, and then once both my in-feed and out-feed are defined, my calculation for the reject will kick in. So right now my in-feed and out-feed are the same. They're both at their max value. I can actually reset those. Give me a second, or I can just leave them at the max values.
Yeah. All right. So then you actually went back to grab a model of the capper and applied that capper to the second machine. It then filled out all of the data that we needed here. And then from there, we're off and running. All right. So then how do we get this data into MQTT? How do we get it to publish?
Yeah. So back in the Ignition gateway, we were setting up our transmitter. The tag path that we're publishing is Ectobox Pittsburgh. So since we're publishing everything underneath the site of Pittsburgh, that data is already being pushed out for the second capper.
So you mean to tell me you've performed some more magic? All right. So
yeah,
then
you can see it that way.
Let's
right.
let's see it.
So while that data is populating out into Canary here, like you mentioned, Kevin, we can go ahead and show off some of the application features. So it does take a minute for that data to get into Canary and for Canary to start logging it.
Great. So we'll wait for that data. So yeah, so this is the second type of visualization, if you will, that we can create in Axiom. All right, let's see what you can do.
So we can do simple stuff like bring in a donut gauge, for example, and I'll stick with my heating temperature here. I can put the PV on there, and you can see that populating out, it ramping up. You can modify some of the visualizations. You can put in a comparison. So maybe I wanted to compare it to my set point and change the color if I am below my set point. So get that red sort of outline there. I can modify my max scale. Let's just put it at 350. So you can see that customization there, as well as some other nice components that we have. So we can do some different types of charts in here. We can put in a bar graph, for example, put in our in feed and out feed and our reject, and see by default this will show the last hour and 15-minute aggregates. So you can see how that's been changing over time with your in feed and out feed. Again, there's a whole bunch of options over here. You can change that time duration, change how it aggregates. You can really get pretty complex and fancy with this.
So a lot of different tools or widgets to throw into the visualization tool, a lot of flexibility for every single one of them. You can make some of these widgets dependent on what you're selecting, and others you can can create the a whole set of widgets that are for different machines and have them listed out or displayed in columns and rows of data. And as new machines are displayed or added to the whole setup, then the new machine will be added to the list. What else? We've seen, and you've done this too, to actually create an iframe within a perspective module within Ignition to then display a Canary report, because this is simple HTML5, so it's pretty straightforward there. So it's a lot of flexibility, outrageous levels of flexibility on this tool. And I'd say too, one of the things you can kind of tell based on the fact that we're actually using this tool and the excitement that I have about talking about this tool is that it's really good. As it's been explained, compared to some other well-known historian products with a lot of capabilities, this one has nearly 100% of the features at 10% of the cost. They're great people. They're actually located close to us in Pennsylvania, as it happens. They're installed in 70 countries, 20,000 installs, I think, or over 20,000. That might be low too. There's a whole lot. A really well-known product, well-baked, been around for 30 plus years. Love the company, love the people, love the product. So it's a really good one. Yeah, really nice visualizations you just created there too. So what do things look like for that data coming in? Is it in yet?
Yeah, let's take a look at that.
Okay, so we've got the data. Frank has come back to the data set, and we've got Capra2 showing up.
Yeah,
It didn't really take that long at all.
no, just a couple minutes there. You can see, like Kevin said, we have Capra2. We have that same structure as Capra1. So I can see the heating temperature, PV. I can refresh it and see those new values coming in. And we can, hop back over to Axiom. I can make a new chart and throw my heating temperatures on there. So all the same functionalities coming in for Capra2 as Capra1.
Nice. And if you wanted to, you could have a chart or an app in Axiom show both machines too.
Yeah, you can get really complex with Canary. You can actually do some data lake modeling in there as well, set up some assets. And they have a whole asset view where based on what assets you have configured and the number of those assets, you can sort of make templates of views and just have those sort of auto-populate as new assets get added as well.
Good stuff. Good stuff. Okay. So let's do a wrap. When you stop your share, I'll start my share.
Mm-hmm.
Just to go back through that diagram and the list again, just to make sure that everybody got what we were doing there. So again, we were connecting to a couple cappers, the PLCs for the cappers, pulling the data via OPC into inductive automation's ignition product, and then publishing that data, turning around with the transmitter, publishing that data as MQTT Spark-Plug-B to HiveMQ in the cloud. And then we were, for this specific situation, we were using Canary to subscribe to the data, comes in automatically once you set up that the data set within the MQTT connector, and then data is stored. And then we went over to Axiom and created a couple visualizations. And then after that, went back, created or set up a second machine in Ignition using the model for the capper. Data took a couple minutes or so to come back over or land in Canary, and then we were able to display that as well. So really straightforward solution, went really, really well, went very smoothly. Murphy was not here today. He didn't visit us for Murphy's Law, and I think it worked out really well. And these are the steps that we went through to do that whole connectivity setup. So with that, if you have any questions, please feel free to reach out, throw them over into the comments in the below this YouTube video. We welcome any questions, comments on this video or anything else. Please subscribe to our channel as well, and come over visit us at our website. We're making constant updates on that website all the time, ectobox.com. And if you want to talk to anybody, please feel free to reach out to any one of us. Frank, thank you so much. Great webinar yet again. We will see you on the next webinar in this series on the UNS, which is on the building out an MES and connecting the MES to the unified namespace. All right. Thank you very much.
Thank you.